Hello guys, so we are back again. Okay, so from this next chapter, okay, from this next lecture, okay, from this lecture onwards, we will try to solve questions. Okay, we will not focus on theories. Okay, I don't have, means I cannot have that much time now. Okay, so I will do questions. Okay, and I can guarantee that I will cover almost you can say 98% of the theory, okay, while solving question only. Okay, so if some few are left, so after, if some means some theory extra part is left, I will cover it after I complete the syllabus, because I don't have time currently now. But I will do a lot of problem which will give you idea of how to solve questions. Okay, because our main purpose is to make you understand how to solve questions. Okay, because that will make you eligible for admission at IITs and NITs. Okay, now we are going to start with AP, as I told you in your previous lectures. Okay, that we will begin with AP. Now before beginning with AP, I want to just make sure that you know some basic things. Okay, let me tell you what basic things. Okay, first basic thing are, okay, let me AP, okay, arithmetic progression. The basic things are that you should know A, what is first term. I will frequently use this A, which is first term. D, difference. Tn, last term or general term, they can say last term or general term okay, and now let's begin with some basic things. Okay, that is the first problem which I am going to give you is this. Okay, we will start with basic problems in AP, and then we will move to how we will create some shortcuts. Okay, so that we can calculate things easily rather than wasting a lot of time. Okay, so let's just begin. So the first question is, I am giving you a sequence. I am giving you a sequence. Okay, the sequence is 1 5 9 13 17. Okay, so the first question is find T25. Okay, these questions are simple. Okay, which is just application of general Tn formula, A plus n minus 1 into D. Okay, which is 1 plus 24. Here you will place 25 minus 1, okay, into D, which is 4. D, how you find D? 5 minus 1, okay, which is 4. Now you get the answer, which is 96 plus 1, 97. Okay, so first problem is done. These are basic questions. Okay, I am doing some basic questions in the starting, so that it will boost your confidence. Now we will do one more question. Okay, which is on the basis of that this series is given 1 4 7. Okay, find S8. Okay, first always get A, D, which is 3. Okay, now Sn has two formulas, n by 2 bracket 2a plus bracket n minus 1 into D, and the other formula is Sn is equals to n by 2 bracket a plus Tn. How I got this formula? This is just modification of this. Just see this, n by 2, I will keep one a here, and this a plus n minus 1 into D, and if you remember, this is what? Tn. Okay, so I can write it n by 2 a plus Tn. Okay, just this. Okay, so these two things are important. Now for this I want to find S8. Do I know the last term? No. So we will just try to apply the direct formula, which is n by 2, 8 by 2 bracket 2a means 2 plus n minus 1 means 7 into D, which is 3. The solve is done. 4 into 2 7, 21 and 23 into 4, which is nothing but 92. Okay, so we got our answer as 92. Now let's move on further. Okay, now let's see, means what I'm going to tell the shortcuts. Just see this. Okay, this will help you more than things which we are learning. Okay, the things. Now just see this question. Okay, the first question which I given you, okay, which I gave you was find t25. Okay, t25. Now the shortcut tricks. Okay, just what is tn formula? A plus bracket n minus 1 into d, which you have a plus nd minus d. Now nd plus a minus t d, just write this n into d plus t. Okay, now remember this, you have to find d and subtract it from the first term. Okay, and write the difference, okay, with n. Your job is done. Okay, now let's find 25 using this. Okay, we calculated 4 into n plus 1 minus 4, which is minus 3. Okay, 1 minus 4 minus 3, so 4n minus 3. So our job is done so fast. Although you will say that it is just the same thing, no, it will just save your time. Okay, first find the d, like here the d is 4, multiply the 4 with n, then first term minus difference, which is 1 minus 4, which is minus 3, so we got the general term. Then put 25, your job is done. 4 into 25 minus 3, okay, which will give you 100 minus 3, okay, which is leading to 97 only. Okay, so we got the same answer. Okay, that was the main thing. Okay, now if the main thing which I'm going to tell you, that this is one more extra thing which you should know, that if a function of formed like this form, okay, 3z plus n, okay, 3z plus constant, okay, like this, 3z plus 8, okay, it is a constant. Now if it is given, you can now recognize it is equal to nd plus t. Okay, then this function will form an AP. It will form an AP with d. You can say d is equals to 3. Okay, so whenever a function of form, what form, okay, it will be useful. A form f of x is equals to 3 into x plus some constant is given, it will form an AP. It will form an AP with d is equals to 3. Okay, so this was the thing we should know. Okay, this was the trick. Okay, try to use it again and again so that you can calculate faster. Okay, this will increase your speed only. Okay, now further let's take some more problems. Okay, let me take some more problems. Okay, the next problem is this 5, 11, 17. Find tn. Okay, general term, how you will find 11 minus 5, just try to calculate d, which is nothing but 6. Okay, you got the 6 into n, 5 minus 6 minus 1. Okay, just job is done so fast. Okay, the same thing while you do, you apply a plus n minus 1 d. Okay, it will consume your time, so try to use this. Okay, when some complications appears in questions, then try to go with the general way. Okay, I will tell you how. Okay, you will understand yourself. Okay, when you solve question. Okay, so let's start with questions. Okay, and hope you have understand the summation formula. Derivation part you can refer to book. Okay, there is nothing great in derivation. Now let's see this. Now we will start doing questions. Okay, the questions are like this. Find the max possible sum of AP. Okay, it is telling find the max possible sum of AP. So in these type of questions, first you should understand the question, that it is telling max possible sum of AP. And now just see this sequence. Okay, sequence is what, 39 7 35. It is reducing continuously. Okay, so at some point it will be negative, and before that it will be positive. So we want to find this last term. Okay, now let's assume that the last term is 0. Okay, so it should be tn. Okay, we want to find that tn. A what we have, 39 plus n minus 1, okay, into d is what, 37 minus 39, which is minus 2. So we have minus 2. Okay, now when we do multiply this, okay, what we have, 41 plus minus 2n. Okay, when we move it, we get 41 by 2, which equals to n. So n is equals to 20 point something. Okay, So 20.6 like anything, okay, doesn't matter, we don't need to calculate it. Okay, 29.5. okay, just the value which it is rounding of this, if it was 17.3 we would take 17, if it was 16.3 we would take 16. Okay, so like that. Okay, when there is a any point, you just take the value before it, 17. Okay, like this. So we got the means the n at which there is a last positive number, which is n is equals to 20. Now we got n. Okay, these type of problems are very common in AP. Okay, so 20 placed t is equals to 20, we need to find out. Okay, so okay, max possible. Okay, sorry, we want to find the sum. Okay, now you got the n, your job is done. S20 you need to find out, which is 20 by 2 bracket 2 into a means 39 plus n minus 1. Okay, 19 into d is what, minus 2. Now you can calculate. Okay, if you had used tn, it would be tn. Okay, last term. Okay, you have to calculate last term, that is also a job. Okay, so you can get the answer from here. Okay, the main point of this question was to understand how you will find the last positive term. Okay, which is the last positive term. Okay, the 20th term is the last positive term. How you will get? First place tn is equals to 0, we will assume that the last term is 0. Okay, when we will solve, we will get some irrational number. Okay, if we get perfect number, it means that the last number is 0 exactly. Okay, so if we get something like this 20.53, okay, so the value which it is rounding up like 20. Okay, just value before it. Okay, 20 point like this to 20. Okay, so we'll take 20. So at n is equal to 20 will be the last. Same goes for you can if they do for negative, the same will appear. Okay, you will use 0 only. Okay, so then you can get whatever they asking. Okay, this is very general question. Okay, in AP. Now let's see the second question. The main point was you should know how to find the last term, last positive term, last negative term, then you can find the sum. Okay, if you don't know how to find the last term, then this question means that in when we move forward, we will see some question which will use combination of this concept. Okay, so let's move forward. The next question is this. Okay, this is the next question, which says the first, second and the last term of AP are xyz respectively, then show that its sum is this. Okay, we want to show that its sum is this. Now what we have been given, a is what, x. Okay, so the second term is what, t2, they have given y, and the tn is what, nothing but z. Okay, now they are telling that show that the sum. Okay, sum means s is what, n by 2 bracket 2 into x, because a is plus n minus 1. There is nothing, any point in thinking. Okay, just we will think sn n minus 1, and then we will see what is there anything missing. D, how you will get the second term is this is first term. Okay, so t2 minus t1 will give you d, which will be y minus x. Okay, so this will be y minus x. So you got y minus x. Now what you should do now, our job will be completed when we get n. Okay, now n is missing. So we want to find n. Okay, so when we applied formula, we got that n is missing, we need to find n. So how we will find n? Now this tn will come in picture. Tn is nothing but a plus n minus 1 d. Okay, now if you do by direct method, it will be z is equals to the difference y minus x into d plus first term x minus d y minus x. Okay, so this is becoming complicated. Okay, so here you should avoid this first method. When numerical value is given, you should use this method. Okay, so we will go with this x plus n minus 1 into d, which is y minus x. Okay, and the second reason is our question is similar to this thing. Okay, here n into y minus x plus x minus d, which is y minus x a minus. Okay, now this is correct, but this is not matching with our this thing. Okay, here n minus 1 thing are present, so we can get some value directly. Okay, so which was tn was our z, so we will put z value. After that we got this value. Okay, that was the main purpose. I was using this formula rather than that formula. So n minus 1 into y minus x is z minus x. Okay, so we got one value which I will put y minus. Okay, so when we will put here z minus x, let me take it as a, but our main purpose was finding n. Now let's find n, which is z minus x upon y minus x. Okay, plus 1 should be equal to n. Okay, this was z minus x plus y minus x upon y minus x is equals to n. Okay, now it is what, z plus y minus 2x upon y minus x is equals to n. So we got n value. Now let me take the next page. So what we are going to put all the values of Sn. So Sn was this, Sn was n by 2, and what we have, z plus y minus 2x upon, okay, minus 2x upon y minus x, okay, into we have 2x plus n minus 1. What we got, its value we have got, we had kept it as 1, z minus x. Okay, z minus x. So when we put this value here, we have 2 also. So be careful. So z plus y minus 2x upon 2 into y minus x. Okay, this will be what, z minus x, z plus x. So we got this thing. Okay, now let's see what we needed to find. Okay, z plus x into y plus z minus 2x, y plus z minus 2x upon 2 into y minus z plus x. Okay, so we got our answer. So hope you understand how we got the idea and how we proceeded this question. Okay, now let's move on to the next question. Okay, the next question is the third question. Okay, the third question is as follow. The third question says as follow. If Sn is sum of n terms of an AP, okay, Sn is sum of n terms of an AP, then find the value of this. Okay, we want to find the value of this thing. Okay, now for this question, okay, you should know that what we can think. We want to find Sn. Now for Sn we have one formula. Okay, we want to cancel these terms. Okay, if we put it, it will become more complicated. Okay, so Sn is equals to, okay, now you know this formula, Tn is equals to Sn minus 1. Okay, so for Tn minus 1, it will be Sn minus 1 minus Sn minus 2. Okay, further for Tn minus 2, it will be Sn minus 2 into Sn minus 3. Okay, now let's just see the question. Okay, the question is, if you can see properly, Sn minus, if I write it Sn minus 1, okay, I have minus 2 Sn minus 1 left. If I break it in two parts, this 3 Sn minus 2, then I can write it 2 Sn minus 2. Okay, further this will be 1 will be here, Sn minus 2. Okay, and this will be Sn minus 3. Okay, when I write it like this, see what I get, Tn, okay, minus 2 times 2 will move out. Okay, minus will come out, then we will get Sn minus 1 minus Sn minus 2, like this. Then we can write Tn minus 1. Okay, plus here what, it will be plus only, Tn minus 2. Okay, now what we got, Tn minus 2 into Tn minus 1 plus Tn minus 2. Now we have three terms, this. Okay, we have three terms. Okay, if these terms are in AP, okay, these terms are in AP, so we can get one thing, that now let's place it in order. Okay, Tn minus 2 will be first, then Tn minus 1, okay, then Tn. Okay, so the difference of these two means as Tn minus 1 minus Tn minus 2, okay, should be equal to difference of this Tn minus 1. Okay, if I move Tn to this side, we get Tn minus 1 is equal to what, Tn plus Tn minus 2. So we got this. Now if I put this value here, okay, these two are equal to this, then what I get, 0 value. So 0 is the answer. Okay, we wanted to find the value and we got the value. So this question was based on your based on your common sense, how you use the formulas. Okay, like here if you have put Sn minus 1 formula, then it would had become more complicated rather than being solving. Okay, so try to avoid such things. Okay, and how you can avoid? If you solve many questions. Okay, if you see variety of questions, you will understand how we need to proceed. Okay, so let's move on to the next question. Okay, so the next question is this one. Okay, the next question is fourth question is this one. If an AP, the mth term is 1 by n and the nth term is 1 by nth term is 1 by m, find its pth term. Okay, m keep m into n term. Okay, so let's just try to get TP is what? A plus P minus 1 into D. Okay, if we got A and D, I will get pth term. Okay, and same goes for this. Now let's just understand this. M term is 1 by n is equals to A plus m minus 1 into D. Let me call it as 1, and 1 by m is equals to A plus n minus 1 into D. Let me call it as 2. Now we want to find these two value, and these two are equal. If I subtract, our job will be done. So 2 minus 1, if we do, what we get? 1 by m minus 1 by n is nothing but, okay, when we subtract, okay, when we subtract nd minus nm, these two will cancel out, which will give me nd minus md. Okay, in the end, which we have n minus m into d, and here we have n minus m upon m into n, and these two will cancel out, which will give me d equals to 1 by m into n. Now we got our d. If I put the d value in 1, what we get? 1 by n is equals to a, we want to find m minus 1 into 1 upon m into n. So this 1 by n, a plus mm will cancel out, 1 upon n minus 1 upon m into n. So you can see these two will cancel out, which will give me a is equals to 1 by. So both a and d are equal. Okay, so both a and d are equal. Now we want to find the pth term. Tp is nothing but 1 by mn plus p minus 1 into 1 by mn. So this was our answer. Now for the second part, let me continue here. For tmn, okay, tmn is what? A plus m into n minus 1 into d, which is so 1 upon m into n plus m into n minus 1 into 1 upon m into n. Then what we get? 1 upon m into n, this will become 1 minus 1 upon m into n, these two will cancel out, giving me 1. So t mn term is 1. Okay, so we got all both the answers. Now let's move on to the next question. Let me take this video. Okay, now this is the fifth question. Okay, the fifth question is as follow. The fifth question says the p times the pth term of an AP is q times the qth term. Okay, then show that p plus qth term is 0. Okay, when such type problems appears, okay, we want to prove this. Just try to simplify the given conditions. Okay, if you simplify, you will automatically come to know. And how we will predict that we came to know to the answer? Just see this. Tp plus q term is what we needed to find. A plus p plus q minus 1 into d. So using these two, after solving these two conditions, we will get at some point this equation. If it is equal to 0, this thing, okay, it is equal to 0, then we have proved that p plus q term is equal to 0. Now let's simplify what is given. P times the tp is equals to q times the tq. Now when we simplify it, what we have? P into a plus p minus 1 into d. Okay, here what we have? Q into a plus q minus 1 into d. Okay, now if we bring the things here, what we have? Now we have pa plus p p square minus p, okay, into d is equals to qa plus q square minus q into d. Okay, we got both the things. So p minus q, I brought the things on the right to the left, p minus a, plus this will become p square, okay, minus q square into d, and this will become plus q minus p into d. Okay, now you can clearly see we can remove p minus q. If I remove p minus q common, take it as common, what we have, a plus p plus q, okay, into d, okay, plus there will be minus, okay, this is just reverse, minus d should be equal to 0. Now what we can get, p plus q, p plus, okay, right. So what we are getting, p plus q, so p plus q into a into p plus q into d, okay, p p minus q we took out, okay, so p minus, okay. Now we I told you that when you realize that you got this, okay, your job is done. So you, if you see it clearly, you will come to p plus q minus 1 into d. This is written what, okay, this is p minus q, so this should be equal to 0. So a plus p plus q minus 1 should be equal to 0, which is what we wanted. So we have proved that pth term is 0, okay. Now let's move on to the next question. The next question is this question, which is sixth question, okay. We have already discussed about the summation and product thing, okay, which was the starting of the chapter, okay. If a and b the nth term of an AP, if summation, okay, summation r is equals to 1 to 100, okay, a to r is equals to alpha, and summation r to 1 to 100, a to r minus 1 is equals to beta. Now you will come to know this will form a series, this will form a series, okay. Then the common difference of the APs, we want to find d, okay, the options are like this. Now we want to find d. Now if we open this thing, okay, what we have, it is equal to alpha, okay, what we are given, r is equals to 1 to 100, okay, into a to r. If we open this, what we get, a2, okay, plus a, when we place 2 we get 4, a when we place 3 6, a 8. Similarly if we place 100 we get a 200, okay. We have 100 terms, okay, and the last term is a 200, okay. Here this is plus. Now similarly beta will be here, r is equals to 1 to 100, okay, a to r minus 1. So what we will get at this 1 3 5, okay, like this 7, and at the last what we are getting, a199, right, a199, okay. Now these are also 100 terms, okay. So what we want to find difference, okay. So if I subtract a2 minus a1, okay, it will become d. So we will get the difference. So alpha minus beta, a2 minus a1, okay. So alpha minus beta, okay, we will subtract alpha minus beta, then it will be a2 minus a1, okay. Then what we get, a2 minus a1. Similarly a4 minus a3. Similarly a6 minus a5, okay, like this. The last term will be a200 minus a199, okay. So what we are getting, this will be d, this will be d, similarly it will be d. Now two terms, okay, these are 100, these are 100, okay. When these in 2 to pair, they are forming d, okay. This will be 100d, okay, alpha minus beta, which will give me answer alpha minus beta by 100 is equals to d, okay. So we got the answer, which was second is the answer, okay, second is the answer. So we got the answer. Now let's move on to the next question. The next question, which is seventh one, this is the next question, which is let a1 a2 a3 and a100 be AP, okay, with a1 equals to 3 and, okay, sp, okay, sum of p is given, I is equals to 1 to p, okay, for p is lying between 1 to 100, and for any integer n with n should be between 1 to 20, let m is equals to 5n, okay, m is equals to 5n is given. Then they are telling sum of m terms upon sum of n terms does not depend on n. Then a2 is, they are telling that sum of this and this is not depending on a2. Now what we get the basic idea from this question, that we want to get the sum of these two. Now let's find the sum. Sm, okay, we will think about if we get something idea, because here we are not getting any idea. Sum of, okay, it will be summation of p terms, nothing much than that, okay. And we want have the first term, So this will be m by 2 bracket 2a plus bracket n minus 1 into d. Okay, similarly here we have Sn n by 2 bracket 2a plus bracket n minus 1 into d. Now if we divide, because they want the ratio, okay, this will be m by n 2a plus bracket n minus 1 into d upon 2a plus n minus 1 into d. Okay, we got this. Okay, now what extra? Now they are telling that m is equals to 5n. Okay, m is equals to 5n. Now let's arrange it first. M by n is equals to 2a minus d, I opened it, and nd upon 2a minus d plus nd. Okay, now sorry, this will be m. Okay, this will be m. Okay, so this is md. Okay, now let's substitute the value, which will give me 5n upon n should be equals to 2a minus d plus 5nd upon 2a minus d plus nd. Okay, so this will cancel out 5. This will be with 2 into 3 6 minus d upon 6 minus d plus 5 and d upon nd. Okay, now the thing which I was talking about, now it is still depending on n. Okay, it is still depending on n. Okay, you can see there are n. Okay, and it is telling it does not depend on n. Why we converted m into n? Because they are telling that it should not depend on n. The reason was that. Okay, now when it will not depend on n, if these will become 0, these two will become 0, they are same only. If this becomes 0, then this will cancel out, they both will cancel out, which will make the equation not dependent on n. So let's make this 0. 2a minus d, this is as per condition. So 2 into a is 6, 6 is equals to d. Okay, d is moved over. 2 into 3, a was given 3, so we got d. Now the first term was 3, so next term will be a2, which is needed. A2 will be 3 plus 6, which will be 9. So we got the second term. Okay, this was the question 7th. Okay, now let's move on to the next question. Okay, hope you have got the basic idea. We just did the condition, we followed this, and then things we did the things according to the condition. That condition was told or dependent on n, not dependent on n. So we tried to convert it on n, and we see that when it will not cancel out on, because if it is not mentioned that it is not dependent on m, so we are not converting n into m. Okay, so be conscious while solving the problems. Okay, now let's move on to the next question. The next question is 8th. Okay, the 8th question is, let S1, S2, S3 are sum of an AP of N1, N2, N3 terms of an AP, are sum of an AP of N1, N2, N3 terms of an AP. Okay, so respectively, then S1 upon N1 into N2 minus N3 plus S2 upon N2 into N3 minus N1 plus S3 upon N3 into N1 minus N2 should be. Okay, that we want to find the value of this. Okay, now here is what the things means difference in children come. Now S1 upon N1, you have seen this thing. If you recall, Sn is n by 2 bracket 2a plus bracket n minus 1 into d, right? If I take this n down, what I get? Sn upon n is nothing but 2a plus n minus 1 into d upon 2. Okay, now if we take here, if I put this value here, 2 will come common, so we will move 2 outside. Okay, so what I will write? 2 here, 2a plus n1 minus 1 into d. Okay, n2 minus n3, right, plus this is outside, this will be what? 2a plus n2 minus 1 into d. Okay, into what? n3 minus n1. Further if we add, keep on 2a plus n3 minus 1 into d. Okay, into what? n1 minus n2. Okay, so we got this thing. Okay, now if you understand the basic thing, if I multiply this, okay, we will go 2a into n2 minus n3. The pattern you follow, 2a minus, here this will be 2a negative and here 2 will be, they are going to cancel out. That is what I am telling. Here it will come in plus and here it will come in negative, and here similar goes for here, so we can just ignore the 2a. Okay, just forget the 2a. Then the rest part is n1 minus 1 into d into n1 n2 minus n3. Okay, this is the part which is left. N1 by 2 is still outside, plus n2 minus 1 into d, okay, into n3 minus n1, okay, plus n3 minus 1 d into n1 minus n2. Okay, we should took d also outside. Okay, so in the next step, okay, let's take d outside. Okay, d, if we take d by 2, we took d outside, and now here you can see if I multiply this, here we get minus n2 plus n3, here we are getting minus n3, so it is cancelling out again. So what our main thing is left, n1 into n2 minus n3 plus n2 into n3 minus n1, okay, plus n3 into n1 minus n2. Okay, this was the thing left. Okay, n1 into n2 minus n1 into n3, n2 into n3 minus n2 into n1 plus n3 into n1 minus n2 into n3, okay, upon d by 2 into d by 2. Now if you see, these are cancelling out. Okay, yes, these are cancelling out, these are also cancelling out, and these are also, okay, so this is 0, so d by 2 into 0, which will give me 0. So our this value of this thing is 0. Okay, so this was the problem. The thing was why you need to calculate these things. Okay, these large things, just try to understand that it will cancel out and move forward. Okay, avoid means non-useful calculation, just avoid it, because it will just consume your time. Okay, because the thing follows a particular pattern. When such things appears, it gives you idea that you should be do some calculations, like you should avoid these waste calculations which are not in purpose and they will cancel out in future. Okay, when you move on to the next steps. Okay, so this was it problem. Now let's move on to the next problem. The next problem is this, okay, which is if a comma b comma c comma d are four unequal positive integers which are in AP. Okay, we want to prove this. Okay, so the one thing which I know, that if it is AP, then if a is a, okay, then b will be a plus b, a plus some d. Okay, d is here, let me take it as m. Okay, it will be some m. Okay, b will be, now the c will be a plus 2m, and same d will be a plus 3m. Now we want to prove this. Now these three options are the same only. Okay, it can be less than this, it can be greater than or equal to. So if I take a by b plus 1 by d, a upon 1 by b plus 1 by c, if I divide it, if it is greater than 1, then we will prove this. If it is less than 1, then we will prove this, and if it is equal, it will be equal to 1. Okay, now let's try to get this and substitute the value. So a plus d upon ad, okay, into b plus c into bc. Okay, so this should be, we will just try to calculate this value, a plus, this will be a plus p, okay, right, and a plus 3m, okay, 3m. So we got this, and now a plus m into a plus 2m upon a into a plus 3m. Okay, here from here, and a plus m plus a plus 2m. Now if you see a plus m, a plus 3m, okay, these two will cancel out, which will lead me to a plus m into a plus 2m upon a into a plus 3m. Okay, now let's just calculate this. A square plus 2am, here am, so 3am plus 2m square upon what we have, a square plus 3am. Now here you can see 1 plus 2m square upon a square plus 3am. So it is surely greater than 1. Okay, so the greater than 1. Okay, it is greater than 1. So it has been proved it is greater than 1. Okay, so we got, now we have to prove this. Okay, now let's just think about it. What it is given? It is given 1 by b plus 1 by c, okay, is greater than 4. Then we will move, okay, we will multiply this here, a plus d. Okay, and we want to just check whether it is greater than 4 or not. So a plus d, a plus what, 3m, okay, into b plus c upon bc. Okay, right? Okay, now 2a plus 3m, okay, this will be a 2a m 2m 3m upon a plus m into a plus what, 2m. Now if you see properly, this is just a square 2a plus 3m the whole square upon this multiplication a square plus 2am plus m, 3am plus 2m square. Okay, we got this. Now if we open that thing, 4a square plus 2 to the 4, 4 is a 12am plus 9m square upon this thing, which is a square plus 3am plus 2m square. Now we want to get this term similar to this. If I take one m out and take 4 common, a square plus 3am plus 2m square plus m square upon this a square 3am plus m square 2m square. Okay, this 4 will cancel, this thing will cancel out, and this will give me in the end m square upon a square plus 3am plus 2m square. What I get, it is surely greater than 4. Okay, because 4 plus something square. Okay, so it is surely greater than this. So fourth D option is also correct. So B, okay, C and D are the correct. Okay, now let's move on to the next question. Now the next question is like this. Okay, now let's just let me remove this page. Okay, the next question is, just show that the sequence this 9, 12, 15, 18 is an AP and find its 16th term. Okay, these are some basic questions, okay, which I took. Okay, so we want to find the 16th term and then general formula. As I told you, just in such problems, don't waste your time. Okay, some small steps in such big questions. Okay, just try to get it using the shortcuts which I taught you. Okay, you know D is what, 12 minus 9, 3. You have a 9, just write Tn directly. 3n plus 9 minus 3, which is 6. Okay, you got the Tn, straightforward. Okay, now you want to find the Tn, which is 3 into 16 plus 6. Okay, 48 plus 6, which will give me in the end 54. Okay, so we got T16. Okay, T16. Okay, T16 we got, which is 54. Okay, now let's see the next question. Show that the sequence log A, log AB, log AB square is an AP. Find its general term. Okay, and term. What that is general term. Okay, now how we will proceed. If you see, the first term is log A, the second, this is a sequence. Okay, log A plus log B. The third term is log A plus 2 log B. How I did it, this is the basic application of logarithm properties. Okay, nothing great in that. Okay, if I subtract these two, I get D, which is log B. If I subtract this, I get the similar log B, which proves that it is an AP. Okay, you subtract these terms, you get D, and you subtract this. Remember, A2 minus A1 is equals to constant is the condition of an AP. Okay, A2 minus A1 is the constant, means it is giving similar value. Okay, A3 minus A4, A4 minus A3, A6 minus A5. If all the values become constant, then it is surely an AP. Okay, this is the properties, okay, which is taught. So we will use its application, which will give me D is equals to log B. Okay, I got D is equals to log B. Now I am for sure that it is an AP. Now I want to find Tn term. Tn term is what? I got D. I got first term, which is log B into n plus log a minus log b, which will be a by b. Okay, so I got my general term. You can further simplify it depending on your means your how you like. Okay, in what form the answer is given. Okay, so we are done with these two questions, 10th and 11th. Now let's see the question number 12th. The question number 12 says as follow: in a certain AP 5 times the fifth term is equal to 8 times the 8th term, then prove that 13. And now see this is the similar question which is coming in numerical form, okay, with numbers. Okay, how we will calculate PN? Just directly. Okay, in such problems just try to write it. 5 times the T5 means A plus 4D. Here it is 8 times A plus 7D. Okay, 8 times 7D. Now you can come to know that this is 3A. Okay, and this is 56. Okay, 56D minus 20D. Okay, now you see 3A plus what? This is what? 36D. Okay, 36D 36D. Okay, so you came across this condition. Now let's see T13. T13 is what? T13 is A plus 12D. Okay, but we are getting 3A plus 36D. If I take 3 common, what I get? A plus 12D. Okay, A plus 12D, which says it is equal to 0. Here it will be equal to 0 because everything is moved to the right side. So we proved that it is equal to 0 from this condition. Okay, so this was the question number 12. Now let's move on to the question number 13. Okay, the question number 13 is as follow: find the terms of the sequence, okay, which is numerically the smallest. Okay, we want to find the sum of the sequence which is numerically the smallest. Okay, now just see this thing. We have first term a1 is equals to 25. How you resolve this term? This term is written 22 by 3 by 4 is written like this: 22 into 4 plus 3 upon 4. Okay, which is nothing but 88. Okay, 88 plus 3 91. Okay, 91 by 4. Now you want to find D. D is what? 91 by 4 minus 25. Okay, this I will multiply and divide by 4, it will become 100 upon 4. This is minus 9 by 4. So we are getting D minus 9 by 4. Now you want to find the numerically the smallest term. We want to find the location at what end the numerically smallest term appears. And here you can see numbers are decreasing. So it is just the application of what we learned, that find the least positive term. Okay, sum of the least positive term. So we will just take 0 is the last term. Then a is what? 25 plus n minus 1 into d what we find out 9 by 4. If I move that side, 25. Okay, 25 into 4 by 9. Okay, plus 1 should be equal to n. What I get? 100. 109 by 4, 109 by 9. Okay, so I get 9 and I got. Okay, so if I divide this thing, I get 12 point something. Okay, 1. Okay, yes, 12 point something. So I will take n is equals to 12. Now for n is equals to 12, we want to find the Tn, find the term of the series which is new. Okay, so 25 plus 11 into d, which is 25 plus 11 into d, we have 9 by 4. So which is 25 minus 99 by 4. Okay, when I divided the 100 minus 99 by 4, which will give me 1 by 4. So we got the least possible number. Okay, numerically the smallest, which is 1 by 4. Okay, now let's move on to the next question. The next question is this. Okay, this is the next question. Okay, the next question says as follow: if pth, qth and r term of an AP are ABC, okay, then show that this thing a into q minus r plus b into r minus p plus c into p minus q is equals to 0. Now how we can show this? Now the pth term, okay, now a is equals to a plus, okay, A plus, okay, we will take capital A, okay, capital A plus P minus 1 into D, okay. Similarly B is equals to A, capital A plus Q minus 1 into D, and C is equals to A plus R minus 1 into capital D, okay. Okay, we got this. Now we want to find this. Okay, now from A we want to prove the A that it is equal to 0. What we can do, just put the values, there is no other way here. A plus, we have the values, A plus P minus 1 into D, okay, into Q minus R, okay. Similarly put the values here, A into A plus Q minus 1 into D into R minus P plus C what we have, A plus R minus 1 into D, okay, into what, P minus Q, okay, is equals to 0. Now you can see, if I multiply P minus Q with this, now the same logical aptitude if you will apply in AP, these things are very crucial. A into Q, you know, here it is following a particular pattern, so this is useless, it will become obvious, so I calculate it. Further, if I take D common from here, what I have, P minus 1 into Q minus R plus Q minus 1 into R minus P into R minus 1 into P minus Q. Further, you see 1, if I multiply it, is again cancelling out, so why calculate that, minus R, Q into R minus P. This is the basic things which you should know already, okay. Teachers are not going to teach you this thing because you are in class 11th, okay. So this will be PQ, PR, QR, QP, RP, RQ. Now PQ, okay, PQ will cancel out, PR will cancel out, QR will cancel, so we are getting 0, which we showed that we have to show that this is equal to 0, and we have proved that it is equal to 0. Now let me take the next page, and we would to prove B. Now B, how we can proceed, this is not like that we can put the value, it is telling A minus B into R, so let's just get the A minus B value. A minus B is what, capital A plus P minus 1 into D minus capital A minus Q minus 1 into what, D. We get that D will cancel out, which will in the end give me P minus Q into D, okay. Now I got for A minus B this, for B minus C why calculate, just apply this aptitude again, okay, this logic, B minus C, I get P minus Q, so here it is Q minus R, okay, Q minus R into D. Try to save the time as much as you can. C minus A will be what, C minus A will be R minus P into D. Now let's put these values in these things, okay. When I put this value, A minus D is P minus Q into D into R plus B minus C is Q minus R into D into P plus R minus P into D into Q. Now if I take D common, what I have, PR minus QP minus RP RQ minus PQ, okay. D I have to common D. Now PR, okay, PR is cancelling out, QR is cancelling out, QP is cancelling out, so we got it equal to 0, so which proves our second point, okay, that this is also equal to 0, okay. If you apply this type of approach to a problem, your calculation just reduces, which gives you time, okay. Just it will help you only, okay. When you appear for the exam, it will just help you out. Now let's move on to the next question. The next question is question number 15, which says as follow, that consider the two APs, okay. S1 which is 2, 7, 12, 17, and it has 500 terms, okay, while S2 which is 1, 8, 15, 22, 300 terms. Find the total number of common terms, also find the last common term, okay. So how we can proceed now, here for the first sequence we have A1 is equals to 2, and for this sequence let me call it as capital A1, okay, and for this capital A2, this is nothing but 1. Okay, and the D, okay, D1 I will call it, it is 7 minus 2 5, and for this D2 is what, 7. Okay, we have, so we have A1 equals to 2 and D1 is equals to 5, A2 is equals to 1, D2 is equals to 7. Now these are 500 terms, it has 5. Now let's find T500. T500, what we have, T500 will be 2 plus 499 into D. D is what we find out, 5. Okay, now if we calculate this, we get 500. Let me calculate it. Okay, we get 2497. Okay, similarly let's find the value of this T300 term, which will be 1 plus 299, okay, into D. D is what, 7. If we calculate it, 207 31 minus 127 277. Okay, we have 2094. Okay, so so we got this, means last term of this sequence. Okay, now find the number of common terms. Okay, now the one thing which you should know while solving this problem is that the AP of this D1 is 5, while the D2 is 7. This is telling find the number of common terms. Okay, this term in this sequence, the term which is similar to this term which is present in this sequence. Okay, such terms exist when the lowest common multiple of D we found out. Okay, that D is the D of the sequence of the common terms between these two series. Okay, so what is the LCM of this? Lowest possible multiple is 35. 35. Okay, 35. Okay, we got LCM, lowest common multiple, okay, which is 35. So 35 is the multi, so we want to just find the first common term. Okay, after this, if we add here further, okay, 5, what it is, it is to be 22. Okay, and here we can see here the first term which is common is 22. Okay, so the first term of this, let me call it S3, it has first term 22 which is common. Now we know that this series will have D, the LCM of these two, as its D. Okay, so what we will have, 57, and then what we will have, 92. Okay, now it is telling, now we got the series, find the common term. Okay, common term, common, so we got the series. Now we want to find the last common term. Okay, common term, so we got the D also, so last term. Okay, for that we want to predict at what n there will be the last term. For that, now let's this has large number of terms while this has lowest number of terms. Okay, now let's take that its last term is the common term of this. So what we have last term, 2094. 2094 is equals to A plus, okay, n minus 1. Okay, okay, 2093. Okay, 2093 into D, 2093 into D. Okay, 22 plus 2093 into 35. Okay, into 35, this should be 2920. Okay, why I am taking n, sorry, n minus 1 into 35. Okay, so 22 plus the n minus 1 into 35. Okay, okay, so now 2094 minus 22, okay, upon 35 plus 1 should be n, and let me calculate it. We are getting n as 60.2 something, so n will be something 60. So at 60, at n is equals to 60, common term will, the last common term between these two series will exist. So now let's find the T60. Okay, our job is almost done. Now I am finding it here, T60. Okay, T60 is what, A, which is 22 plus 60 means 59. Okay, into D, D is what, 35. If I calculate it, what I get, 22 plus 395 into, okay, 35, which is wait, let me calculate this. Okay, let me calculate. So we are getting 2065. Okay, 2065. Okay, so 22 plus 2065, which will give me 2087. Okay, so we got T60, which was the last common term between those two series. Okay, so this was our answer. Now let's move on to the next question. Okay, the next question is question number 16. Okay, the next question is question which is, if a1 comma a2 till an are in arithmetic progression, okay, where a1 ai is greater than 0 for all I, then show that. Okay, ai means 1, a1, a2, a3 all are greater than 0. Okay, then we have to show this, that 1 upon under root a1 plus under root a2 plus 1 upon under root a2 plus under root a3 plus like that 1 upon under root an minus 1 plus under root an is equals to n minus 1 upon under root a1 plus under root an. Okay, now what thing which we can do, the first thing which I am means what I can predict is rationalizing. When I rationalize, what I get, a1 minus under root a2 upon this a1 minus a2. Okay, similarly here what I will get, here I will get a2 minus under root a3 upon a2 minus a3 until the end, means from here till the last number, which is what I will get here, an minus 1 minus an upon what, an minus 1 minus an. Okay, now you know a1 minus a2 is minus d, so if we move this, what we can write, a1 minus under root a2 upon minus d. Okay, similarly here I can write 8 under root a2 minus a3 upon minus d. So on after this I can write an minus 1 minus an upon minus d. Now all the denominators have become same, so I can add them. So if I add them, you can see minus a2 plus a2 minus a3 and so on. So this term and this term will be left. Okay, so what I'm get, under root a1 minus an upon minus d, and if I take minus common here, then what I get, an. Okay, sorry, this will be not under root. Okay, yes, it will be under root and so here will be under root an minus under root a1. Okay, so this will be under root an minus under root a1 upon d. Okay, we got this. Now if I rationalize it again, what I get, an minus an upon d into an plus a1. Okay, now what we have, now if you see, an is what, an is a plus n minus 1 into d, while a1 is a only upon d into an plus a1. Okay, this will be under root. Okay, under root a1. Now let me take the next page. Okay, this page also. So what we have, the final equation, we have final equation as a plus n minus 1 into d minus a upon d into under root an minus plus under root a1. Okay, so here a will cancel out, giving me n minus 1 into d, and d is same down there, under root an plus under root a1. Okay, dt will cancel out, which will give me n minus 1 upon under root an plus under root a1. So we got the answer, which is under root n upon n minus 1 upon under root an plus under root a1. Okay, so our main task was to prove this, and we have proved it like this. Okay, so we have done this problem. Okay, we have proved it. Now let's move on to the next question. The next question is question number 17. Okay, the question says as follow: if p comma q are terms, okay, not necessarily consecutive of an AP, then prove that there exists a rational number k such that r minus q is equals to p, r minus q upon q minus p is equals to k. Okay, that k number. Hence prove that the numbers under root 2, under root 3 and under root 5 cannot be the terms of a single AP, okay, with non-zero common difference. Okay, so they have given a condition, and here the only thing which I am getting idea is we want to satisfy this condition. Okay, if it satisfies this condition, then we will move forward. Okay, forward, and we will see what we are getting from this condition actually. Okay, and that thing is only what we are getting. Okay, so the pqr are the terms. Okay, now let mth term is p, tm term, tnth term is what, q, and t, okay, m and k term is what, r. Okay, now what we have, p is equals to a plus m minus 1 into d. What we have, this q is equals to a plus n minus 1 into d. R what we have, a plus r minus 1 into sorry, k minus 1 into d. Okay, so we got this. Now r minus q. Okay, r minus q will be nothing but let me get r minus q. A will cancel out, this d will cancel out, which will give me r. K minus q means n, k minus n into d. Okay, so similarly q minus p will give me, where is q, n minus m, okay, into d. So and k, okay, and this thing I will get, okay, k minus, okay, so we are getting r minus q upon q minus p should be equals to k minus n upon d upon n minus m into d. So dd will cancel out. R minus q upon q minus p should be equals to k minus n upon n minus m. Now they are telling, prove that the number under root 2 comma under root 3 and under root 5 cannot be the terms. Okay, so so if I take lm, now listen what I am telling. We have told that it is p term, it is q term, it is r term. Okay, then sorry, m term, n term, k term. Okay, and now when I say m term means it is an integer. Okay, I said 6 term of this series, 7 term of this sequence, 8 term of this sequence, so they are integers. Okay, so m, n, k are integers. Okay, now let's take this 3 as this value. Okay, it should, if it satisfy this condition, then it will be right. So under root 5 minus under root 3 upon under root 3 minus under root 2 should be equal to k minus n minus m. But these are integers, integer cannot give irrational number. Okay, okay, so it is not true, so they are not satisfying the condition, though these cannot be the terms of a single AP. Okay, so this condition was the main thing which you want to realize. Okay, many children, what do they just divide, means they just divide this number, okay, and get this k value. Okay, get this k value, they just divide this number. Okay, let me think, they just divide this number and get this k value. Okay, okay, so okay, they instead what they do, they equate it to k, which create a misery, so don't do such things. Okay, I should have not taken k, instead k is something else. Okay, k I should have not taken k. Okay, k is something else. Okay, k is if I means I did a mistake, means I should not have taken k, I should have taken some other number. Okay, okay, sorry for that, but the rest of the thing are these only. Okay, the main thing was just you need to realize when how the things will go, how we will use this condition, and to predict that these can be the terms of the AP or not. Okay, so let's move on to the next question. The next question is question number 18. The question number 18 is, if the terms under root a minus x comma under root x comma under root a plus x are in AP and all are integers where a1 comma x is greater than 0, other, okay, greater than 0, then find the least composite value of a. Okay, we want to find the least now these terms are in AP, so it should satisfy this condition. What condition? 2 into under root x should be equal to the sum of the extremes. Okay, under root a plus x. Okay, now if you do this, if you square both, 4 into x should be equal to this, if I square this, a minus x plus a plus x, okay, plus 2 into under root, if I multiply this, it will become a square minus x square. Okay, further this x will come cut out, 4 into x is equals to 2a plus 2 into under root a square minus x square. 2 will cancel out, giving me 2x is equals to a plus under root a square minus x square. Okay, here what will become, 2x minus a is equals to under root a square minus x square. If I move this that side, 4x square minus 4xa plus a square should be equal to a square minus x square. A will cancel out, which will giving me 5x square is equals to 4xa. X will cancel out, giving me 5x is equals to 4a. So we are getting a is equals to 5x by 4. Okay, so for x is equals to 1, we have a is equals to 5 by 4, which is not a compositive value. For x is equals to 2, we are getting a is equals to 5 by 2, not a so we want to get some. Let's try. For x is equals to 4, we have 5 into 4 into 4, which will give me 5. 5 is a prime number. Okay, it is not composite number. Composite number means it should have a multiple of a number, okay, other than 1. Okay, so what we have for, let's try, it means next number which is multiple of 4. Okay, so it will create 2. Okay, now if we try for 8, okay, if I try for 8, it will be a is equals to 5 into 4 into 8. 5 to the 10. Okay, 5 to the 10 2. Okay, least value of a 2 into 5. Okay, this can be broken into 2 into 5. Okay, and 2 into 5, so we are getting a is equals to 10. Okay, but 2 into 5. Okay, these are this 10, these 2. Okay, we are getting 2 into 5, which is multiple of these 2. Okay, so composite numbers are multiple of, okay, multiple of some number other than itself. Okay, so we got the 10. Okay, now let's move on to the next question. Okay, the next question is question number 19. Okay, the question number 19 is, if b plus c minus a upon a, okay, comma c plus a minus b upon b, comma a plus b minus c upon c are in AP, then prove that 1 by a, comma 1 by b, comma 1 by c are in AP. Now just listen to the properties. If I say a comma b comma c are in AP, then and d comma e comma f are in AP. So two APs can be added. If added, okay, if added, the resulting will also be an AP. And if I add some constant b plus k, c plus k, the next sequence will means after this the sequence will also form an AP. Similar goes for division and multiplication, b by k, c by k, okay, and a k, b k, c k, okay, all will have okay, all will have AP. Okay, all will in AP. Now we want to prove this, that 1 by b, 1 by c are in AP. If this is in AP. Okay, so what we can think, if I add, okay, if I add 2 on both the side, okay, all the terms, if I add 2, okay, so here 2, I am adding constant, so it will still be in AP, plus 2, comma a plus b minus c plus 2 upon c. Okay, what I have, a plus b plus c upon a. Okay, a will cancel out. Here a plus b plus c upon b, here a plus b plus c upon c, and so we are getting, if I divide throughout by a plus b plus c, what I get, 1 by a, 1 by b, 1 by c. So this is also in AP. Okay, hence proved. Okay, this was very easy level question. Okay, this question will be taught when the teachers are teaching you in the classes. Okay, now let's move on to question number 20. The question number 20 is, if a b c belongs to r, r plus the real numbers form an AP, then prove that a plus 1 upon bc, b plus 1 upon ac, c plus ab, okay, are also in AP. Okay, now it is in AP, a plus b plus c. Now if I divide throughout by ABC, what I get, a, here I get BC, here I get AC, here I get 1 upon AB. Okay, now we want a plus 1, b plus 1, c plus 1. Okay, what we can do, okay, what we can do now, this is a AP and this is also an AP. Okay, this is also an AP. If I add this both APs, 1 upon b plus c, BC, comma b plus 1 upon AC, okay, and c plus 1 upon AB, so it will also be an AP. So we got our answer, which is this. Okay, this is what we wanted to prove, hence proved. Okay, these are small questions, okay, even though they are not that much important, but I have taken it so that no questions are left. I will take as much questions as I can, okay, because questions are not taught in classes, they rather teach you theory part, okay. So I am just trying to do question part, okay. If A, B, C are in AP, then prove that the following are also in AP. Okay, we want to prove that these three are also in AP. How we can prove? Now the first way is trying to convert this into this, but here you can say it is difficult, a square b plus c, because we are not able to click that, okay. So the next way is to prove that a2 minus a1 is equals to constant. This is also a condition for AP, okay. Remember I told just earlier. So what is this? B square into c plus a minus a square into b plus c should be what? Equal to c square a plus b minus b square c plus a, right? So let's just open it. B square c plus b square a minus a square b minus a square c. Here c square a plus c square b minus b square c minus b square a. Now what we are getting, if I take c common, b square minus a square, right? And here if I take ab common, I get b minus a. Similarly here if I take a common, I get c square minus b square. How I am able to predict this? Because if I take ab common, I will get stuck in taking c minus a, okay. Here I will get stuck in b minus a. If I take b square common, b square common, okay. No, b square, not a square common, okay. So be alert while solving questions, okay. I take a common. Now I am taking plus cb common. What I get? C minus b, okay. Now here it is b minus a, b minus a and b plus a. So if I take b minus a common, what I have left with? I have left with okay, I am left with c into b plus a plus ab, right? And here if I take c minus b common, I am left with a c plus b plus cb, right? Now b minus a is here, okay. B minus, let me see. So it is b c square minus b square, okay, a common. Now here this part I have taken a common, okay. B cb common, so b minus c, okay. So what we are getting? cb plus ac plus ab, okay. I was checking whether I am going wrong or not. So ac plus ab plus cb, okay. So here you can see these two parts are same, so I can cancel them, which will give me b minus a is equal to c minus b. So 2b is equals to a plus c, which is the general condition of AP, okay. Three terms are in AP, then we say this thing, okay. So we have done with this first section. Now let's move on to the second one. Second one is we can prove it like that only, okay. So it is 1 upon under root c plus under root a minus under root b plus under root c. Here similarly 1 upon under root a plus under root b minus under root c plus under root a. What I get? In upward I see that c will cancel out, giving me under root b minus under root a upon this under root c plus under root a into under root b plus under root c, okay. Further here what I have, a will cancel out, finally a minus under root b upon under root a plus under root b into under root c plus under root a, okay. Now what we are getting? C plus a, both the sides c plus a will cancel out, okay. So what we are left with, under b minus a, under b plus a, okay. Now if I move it, it is a minus b, so it will become b square minus b minus a, and here it will become c minus b, okay, which will give me 2b is equals to a plus c again, which will prove that it is in AP. It is in AP, okay. So we are done with this thing, second one. Now let's move on to the third one is like this, a upon b plus a upon c is equals to, okay, is equals to okay, b into 1 by c. I should have wrote it like this: c upon 1 by a, 1 by b. Okay, now what we can do, if I take a common and multiply the c plus b upon bc, okay, right, and here a plus c upon ac, right, into b, and here c into b plus a upon ab, right, and if I multiply a inside, I get ac plus ab upon bc. Okay, similarly b into ba plus bc upon ac, and here cb plus ac upon ab. Okay, now further, if I add 1 on both, all like 1 1 1, what I get, ac plus ab plus bc upon bc, further ab plus bc plus ac upon ac, cb plus ac plus ab upon ab. Now if I divide throughout by this thing, I get 1 upon bc, 1 upon ac, 1 upon ab, and if I multiply throughout by a plus b, a into b into c, I get a comma b comma c, which proves that this is equal to this, and so it is also in AP. So it is just reverse. If I convert this into this, then it is also in AP. Okay, so we are done with the third one. Okay, so let's move on to the next question. Okay, there were 3 examples. Okay, these were questions of manipulations. Okay, we have to just manipulate the things, okay, to get the following things. Okay, now the 22th question, which says if the sum of the three number in AP is 24 and the product is 440, find the numbers. Now let me tell you some things. Okay, three term, okay, these things come in GP. Okay, 3 terms, okay, and 4 terms, 4 term and 5 term. Okay, now just see, 3 term means odd. Okay, 3 is odd, so difference will be a. Okay, so a minus d. Okay, a minus d, a and a plus d. If you subtract this from this, the difference is a, which is odd, d. Okay, d is odd, 1 d. Okay, while here if you subtract a minus 2d, a minus 3d, sorry, a minus 3d, a minus d, if you subtract this from this, you will get 2d, which is even, and similarly a plus d and a plus 3d. Okay, so the remembering trick is that when the difference is even, okay, even, you will take the terms like that 3dd, so that the difference is even, and here the difference is odd, and here it will be 5, which is odd, so a minus d. Okay, a minus 3d, a minus, it will give me d. Okay, a minus 2d, a minus d, a plus d, a minus 2d. Okay, you don't need to memorize this, you need to just understand the thing that the difference in odd terms will be d, while in difference in even term will be 2d. Okay, so now let's take the condition of these 3 terms. So sum is a minus d plus a plus d should be equals to what, 24, which is giving me 3a is equals to 24, so a is equals to 8. Okay, now the product, here it will be a square minus d square, these two, and it will be a, which will give me 440. Okay, we have 8, okay, which is 2 into 110, which will give me 5 into 55. Okay, I have this 55, a square minus d square. Okay, now 55 will move this side, and a I have 64, 64 minus 55 will be d square, which is okay, I have this 9. Okay, I have 9, so d is equals to plus minus 3, therefore, okay, so 3 numbers we will get for different d. So d is equals to 3, we will get 3 number, and for d is equals to minus 3, we will get 3 different number, which will be a minus d and a plus d. Okay, this question is from your class 10th. Okay, now let's take the next question. Okay, the next question is question number 23. Divide 32 into 4 parts which are in AP such that the ratio of the product of extremes to the product of means is 7:15. Divide 32 in 4 parts. Okay, So 32 and 4. Now, so we will, here we are getting idea that we will take 4 terms. Okay, how we will take a minus 3d, a minus d, a plus d, a plus 3d. Okay, so we took the 4 terms. Now then they're telling that divide 32. Okay, so that sum should be equal to 32, right? So it should be equal to 32. This all will cancelling out, giving me 4a is equals to 32. So I got a is equals to 32. A is equals to 8. 4 8 is 32. Now similarly, now these are the terms. Okay, now these are extremes and these are mean. Okay, in even number there are 2 middle terms, and while in the odd there is 1 middle term. On the basis of this concept, they are telling that the ratio of the product of extreme to the ratio of product of the mean, that a minus 3d into a plus 3d upon a minus d and a plus d. This concept of middle term and this extreme term is used in binomial. Okay, this is 7 is to 15. So this 7 is to 15. Now we have a value, so put the a value. Okay, this is a minus 3d and a plus 3d, so it will be a square minus 9d square. Okay, similarly here it will be a square minus d square. Here it will be 7 by 15. Okay, right? Now what we can do, just multiply this 15a square minus 135. Okay, 135 into d square, okay, is equals to 7a square minus 7d square. Okay, if I cancel this out, here I get 8a square minus here 7d square will come here, which will give me 128d square should be equal to 0. Okay, a I have what, a is 8 into 8 64 minus 128 into d square. So what we are getting, d are we are getting d is equals to plus minus 2. Okay, so when you use this d for 2 plus 2 you will get different series, and for minus 2 you will get different series. Okay, so these are the answers. Okay, now now what, okay, let's move on to the next question. Okay, so the last question of this video is this question number 24. The question number 24 says as follow: the digits of a positive integer having 3 digits are in AP. Okay, and the sum is 15. The number obtained by reversing the digit is 594 less than the original number. Find the number. Okay, the digits of positive integer having 3 digits are in AP and the sum is 15. Okay, now they are telling that 3 digits. Okay, 3 digit, the digits of positive integer. So 3 digit, it is 3 digits to unit, tens, 100. Okay, 3 places. Okay, so if I, these are 3 terms. Okay, they have given conditions, so we can take it a minus d, a and a plus d. Okay, we are getting idea that we should take a minus d, a and a plus d. So let it be a minus a plus d. Okay, a minus d. Okay, so we got idea of 3 digit number. Now the sum is 15. Okay, so a minus d, a and a plus d should be equals to 15, which is give me a is equals to 5. Okay, so I got one thing, a is equals to 5. Now the number obtained by reversing. Now just understand this thing, that a minus d, okay, a minus d, it is less than, okay, this term, okay, it is a 3 digit number, so this should be 100, while this should be 10, and this will be as it is. Okay, it is what, 100 plus 10. Okay, 111a, and this is 100 plus 1. Okay, minus 9090. Okay, now they are telling that the number obtained by reversing the digit is less than 594. Okay, is less than 594. So what, so just reverse this, means when I write it in reverse order like this, a plus d into 100, okay, plus a into 10 plus a minus d, I have what is 100. Still we have a as 11 and d as plus 99d. Okay, is 594 less than the original? Okay, 594 less than the original. 594 less than the original. So the original one is 594 greater than this. Okay, so what condition we have, 111a, this is the original one, original. Oh, Okay, a minus 99d, okay, is 11a plus 99d plus, okay, this is 594 greater, so if I bring it here 594, it will become minus. Okay, we have a value, so after solving we will have 198d should be equals to 594. Okay, okay, these two will just cancel out, okay, which will give me 194d. Okay, which, so d is what we are getting 3. Okay, d we are getting 3, so we have a is equals to 5 and d is equals to 3. So the number is, what is the number? The number is d is minus 3 into a. Okay, so the number is 111 into 5, which is, okay, okay, 111 into 5 plus 99 into 3. Okay, this is the number, which is 852. Hope you have understand. Okay, because this is the number which we have got. Okay, okay, so we wanted to find the number, so we got the number, which was this 1111a plus 99d. Okay, so see you in the next video, and we will do some more questions on AP in the next video. Okay, this video was long because we covered about 24 questions and explaining it was taking time. Okay, that's why I just means for now I am not explaining the chapter, I am just focusing on questions. Okay, so see you in the next video.